To see that your knowledge of logs and exponents can help you understand an outbreak as it's unfolding, go to the CDC's website and click on the latest CDC outbreak information. Scroll down to find the previous update postings. Each update shows the number of reported cases. So plot the number of cases and the date in an Excel spreadsheet, or download the spreadsheet that's provided. Okay, so add a column to allow us to calculate the number of days since the first report was given. And we'll wrap the text there. Now to calculate that, we want to let this be the value of the March 31st minus the March 24th. So we'll type an equal sign, click on March 31st minus March 24th, and press enter. And it's going to give us our value in a date format. We actually want that value to be in a general format, so we'll click on general with no decimal places. So days since our first report here was 0 days, 7 days here. If we fill this down, we're not going to get our days since our first report. We're going to get the difference between the dates in which they reported. So what we actually want this to be is an absolute reference. We want to have each cell be subtracted from, or subtract the date of March 24th from it. So we're going to change this to an absolute reference of $A, $2. And now when we fill this formula down, we will get the value from the inception point for each one. So next we want to actually plot the data. So we're going to grab these first two columns and highlight the data, the second and third column, and highlight the data, and then go to Insert and Scatter, and choose a scatter plot. Now let's move the scatter plot up so that we can see it toward the top. And as we can see, this looks like it's an exponential growth style graph. So let's bring our graphing calculator in. So you can plot statistical data by clicking on the Stat button on your graphing calculator and then going to Edit. If there's already data in your graphing calculator, you can clear it by arrowing up to the L1 and pressing the Clear button. And what you're wanting to do is place the values of for the time since it was first reported in the L1 column, and then you will enter the suspected and confirmed cases in your L2 column. So when you are finished, if you press your graph button, it looks like nothing has happened, no data is being plotted. That's just because the window size is incorrect for the data we have. So click on Zoom and then arrow down to Zoom Stat. So it will zoom in based on the statistical data that we have. And you see a graph that looks very, very similar to what we saw in Excel. So next we're going to click on Stat and arrow over to Calc. And we recognize that this is likely an exponential growth problem, so we're going to scroll or arrow down to the exponential regression and press enter. And the calculator will calculate an exponential regression based on the data that we have. So it's going to give us a curve of best fit when we press enter. So an exponential regression has the form y equals some number times another number to the x power. And the calculator says that that first number is roughly 88.919, and the base to the power of x is 1.022 approximately. So if we plot that into our y equals, we're going to say that we're taking 919 times 1.022 to the x power, and we're going to ask it to graph that to see how well this curve fits our actual data points. And as you can see, this exponential growth fits it fairly well, but perhaps isn't quite steep enough. But now we can use this equation to figure out or to predict what value y will have, how many suspected and confirmed cases there would be for any time x, the days since it was first reported, or we can say by January 1st, how many confirmed and suspected cases would we likely have. So let's go to Excel and see what equation it comes up with. If we right-click on the data itself, we have the ability to add a trend line. And that trend line, again, has to be predicted based on what you believe this equation to be. It does not look linear or logarithmic or polynomial. We would predict it as an exponential equation. So we're going to go ahead and find the exponential equation. Let's go ahead and display that equation on the chart, and then we'll also display the r² value on the chart. So when we hit close here, we're going to see Excel's curve of best fit that matches the data. And anytime that you get an r² value that is close to 1, it means that it is fitting that curve for that data fairly well. So as you can see, we have an equation here of y equals 88.919 times e to the 0.0218 x power. So now you know where some of these equations come from when mathematicians are predicting values based on given data.